Okay, good morning. Oh, wait, let me double check my monitor. Oops. Test. Okay. So today, welcome back from your spring break. I hope it was at least relaxing. I didn't do anything terribly exciting. And let me close this out over here and close this out over here. Okay. Let me mute this. Okay. So, like I said, today we're looking, as you can see, Chapter 13, Control of Microbial Growth, Section 3, Using Chemicals to Control Microorganisms. This is not about antibiotics yet. That is in the next chapter. And after that, we can roll into the last few chapters, including immunity, before we go into the disease stuff. And that'll be the end of your year. Now, for everyone that's I haven't actually graded the other midterms yet. I just took the week off as well. But I'll wrap that up, by Wednesday at the latest. So let's go to over here so I can see this. And I don't have to look at my little inset window, which maybe I don't even need. Maybe my voice is sufficient. I don't know, man. All the cool kids do it. All right, so again, using chemicals to control microorganisms. We'll get moving here. And yes. Okay, so the learning objective here is to understand and compare the various chemicals used to control microbial growth, including their uses, advantages and disadvantages, chemical structure, and mode of action. So now I would like to introduce you to the phenolics. So this is what Lister first started using in the 1860s. That became all the rage to, not infect patients. Then in Listerine employs phenolics, and that was starting in 1979. So the benzene ring here, as you all should recognize, when you add a hydroxyl to it, an A, so phenol, carbolic acid, it is tends to be stable and persistent. So phenolics are less toxic than phenol, these other ones. But they work by denaturing proteins, disrupting membranes. And then we have the cresols, the methylated phenols, O-phenyl, phenol, and lysol. And then hexachlorophene was discontinued. It was used to be used for bathing infants because it caused neurological problems. And that's C, hexachlorophene. Yeah, don't use that to bathe infants anymore. So the O-phenol, the O-phenylphenol is what your active ingredient is in Lysol. Though the ethanol helps too, right? Listerine. Okay, yeah, sorry. This is Lysol. It's for surfaces. It doesn't have ethanol. Your Listerine does, though. All right, so Triclosan was used for a lot of years as a there's a rap tap tapping on my chamber door. It's my cat, our cat. She can stay outside. So Triclosan was used for hand washing for a long time, and it should no longer be a common ingredient because it was banned in 2016 for that use. So it turns out that Triclosan confers no benefit. Resistance is easily found in a bacterial population because it only takes a single gene mutation in bacterial fatty acid synthesis. Triclosan also will build up in the environment, and which will cause the inhibition of digestion of sewage. Hence, it was banned in 2016. So you shouldn't see Triclosan used anymore. And the reason it's also, it says it right here. your basic soap, the mechanical action of using a surfactant to wash your hands and actually rinse your hands off and just clean your hands is sufficient to reduce the amount of bacteria on your skin dramatically. Triclosan was not useful. But it is an example of a chemical that was used to control microbial growth for a number of years. Heavy metals. Now, so this is a true thing, unlike what some people are trying to tell me that this was woo a long time ago. But anyway, this is called oligodynamic action. Is that phrase up here? Oligodynamic. It mentions it in the book. There's a downside to using this program instead of using Camtasia, is that I can't. Okay, no. There probably is a way to do quick pop-ups, but I just don't know how to do it. All right, so heavy metals. They will denature proteins, impair cell functions, and that gives them strong antimicrobial properties. So copper, like in door handles, would kill microbes that otherwise might accumulate on frequently touched surfaces. The silverware, so actual silverware, that would inhibit microbial growth. Of course, they didn't know that. What is that fork? Look at that fork. It's a fork within a fork. Okay, I ain't got no culture, people. I never saw a fork in a fork before. Sorry, I just noticed that after 4 semesters, the first time. It's a fork in a fork. All right, so copper fixtures, silver, actual silver. Copper is still commonly used in incubators to minimize contamination of cell cultures stored inside. Antiseptic mouthwash commonly contains zinc chloride as another ingredient in Listerine, along with the phenolic, right, and ethanol. And however, so colloidal silver is really popular with a lot of people that want to avoid going to the doctor, and it doesn't not work. You know, it is something that actually does have an effect on microbial growth. It's not near as good as antibiotics or some other, actual treatments for conditions, but it doesn't not work at all. However, if you consume a lot of it, you can develop a condition called argyria, which is caused by the bioaccumulation of silver in the body, and it turns you not really blue, this purplish color. And so the guy that was famous for this, that reveled in the name Papa Smurf, so he did the whole white beard and everything, he died from an unrelated condition within the last year or two. Yeah. But anyway, that's irreversible if you take too much of that colloidal silver. All right, so heavy metals have some advantages. Disadvantage is they're not selectively toxic. The argyria, obviously. So the Silvadene cream, if you've ever used that for burns, that actually is helpful. We used to use silver nitrate drops on the eyes of newborns, particularly if they were delivered vaginally. Instead, we use antibiotics. So heavy metals can help in catheters, bandages. There are bandages that have copper in the bandage themselves. Nickel and zinc, and then again the zinc chloride or zinc oxide. Well, zinc chloride is also, there we go. All right, so moving on to the halogens. So betadine, which you probably have heard of, is a solution of the iodophor, providone iodine. Looks like that. So it's commonly used as a topical antiseptic before surgery. I can't say, I don't know. I was unconscious when I had my last surgery several years ago. So the iodine is a slow release. It will oxidize cellular components. That's its mechanism of action, like sulfur-containing amino acids, nucleotides, fatty acids. It'll attack those things. But it is, This complex allows for the iodine to be released slowly. So chloramines. So we take your ammonia, remove a hydrogen, replace it with a chlorine, and you have a chloramine. So monochloramine is derived from ammonia. It's used as a disinfectant, and yeah, that's all I have to say about that, apparently. Okay, alcohols. Ethanol, isopropanol. You're familiar with these. Ethanol is a great disinfectant. It's bactericidal, it's fungicidal, it's virucidal for the enveloped viruses. It will inhibit sporulation, and you can drink it. Isopropanol you can't drink. That is poisonous. And yeah, so these are common disinfectants that see a lot of use, right? Okay, so surfactants. We're looking at basically soaps. So here's the sodium salt of this surfactant here. So they're the salts of fatty acids, and they have the ability to emulsify lipids, fats, and oils by interacting with water through their hydrophilic heads and with the lipid at their hydrophobic tails. So by emulsifying, you mean you're breaking it up, you're mixing it up into solution. So obviously that would destroy a cell membrane, right? If nothing else, you're at least able to free whatever attachment it has to the surface. And yeah, so soaps will help you wash away. But it does get more difficult to rinse away in hard water. You know, water with a high mineral content. If you've ever showered in hard water, you know this to be true. It's easy to get the soap on, but it's hard to get the soap off. So, quaternary ammonium salts, or quats, is another detergent that is used as a disinfectant and an antiseptic. So it has this quaternary nitrogen atom, which will confer a positive charge overall. And then we have the benzalkonium chloride and the acetylpyrimidine chloride. So, you know, here we go, disrupting the membrane. They're able to infiltrate the phospholipid plasma membrane of the bacterial cell and disrupt their integrity, leading to death of the cell. So the CDC hand washing guide. This is for the general public. It recommends 5 steps as part of the typical hand washing protocol. Let's see, what are we doing? Wet your hand, and then turn the water off to, I guess, conserve water. Yeah. Lather, scrub, rinse, dry. All right. So we have the bisbiguanides, like chlorhexidine. Yes, here we are. They're cationic antiseptic compounds commonly used as surgical scrubs. So they're good on gram-negative, except Pseudomonas aeruginosa. They're poor against Mycobacterium. And, yeah. So I don't know why. It's because I'm out of practice. So alkylating agents. So this is a group of strong disinfecting chemicals that act by replacing a hydrogen atom within a molecule with an alkyl group and activating enzymes and nucleic acids, cross-linking proteins. This is a chemical fixative. So this includes, well, as you can see, formaldehyde, glutaraldehyde, and ethylene oxide, all this stuff. Here's an array of examples here. So peroxygen is our next chemical used to control microbial growth. And of course we have hydrogen peroxide, which is good for killing bacteria, leveraging the damaging potential of free radicals. However, it's not great for wound healing because it also damages our own tissues. but that's, generally peroxides are employed in a lot of contact lens disinfecting solutions. All right, so section 4, testing the effectiveness of antiseptics and disinfectants. Do I remember why I was doing that? Yeah, I guess we'll go over this. It's kind of similar to you already did it in lab, but so I should have had this section before you did that. But let's just go ahead and go through it. So we're looking at disc diffusion, which you're familiar with, use dilution, and in-use methods for testing the effectiveness of antiseptics, disinfectants, and sterilants. And yeah. Okay, so remember you had the zone of inhibition that would appear around your paper disc, which this test works best if you're, with these standardized discs, which is how the antibiotics are delivered. When you're doing the hand dipping the filter paper, with forceps or tweezers, and put that on the plate on the lawn that you put there, it sometimes you have too much liquid physically on the filter paper, so that will diffuse out on its own, so you don't get a real measure of the zone of inhibition. That's probably why you probably had a lot of variance in your results when you were looking at that. I'm paranoid. I need to double check something right quick. No, I'm good. Okay. Hey, 3 viewers. Sorry. Okay. Go back to here. So we measure our zone of inhibition by measuring the diameter. Here, you have these little rulers that are on top of the plate lid. Yeah, so here we're looking at Pseudomonas aeruginosa and Staph aureus with five antimicrobial compounds. And of course, different antimicrobial compounds will affect different organisms in different ways. And here we see the Pseudomonas is only affected at all by this antimicrobial 1. And then over here we have the Staphylococcus aureus, of course, has much larger zones of inhibitions. So this is area where the chemical was present and no growth was able to occur, and that the chemical diffused out, so it's on a concentration gradient. Yeah. Okay, so here is another approach where we are just taking some disinfectant solution, so we can check it with the in-use test for contamination with microbes. So we take the used disinfectant. So this way we're seeing if any of the microbes that were, used or treated with the disinfectant are still alive. So we incubate them. So here, if we, if you grow, so place 10 drops on each of 2 plates, growth of 5 or more colonies on either plate indicates contamination of the disinfectant solutions. That's the in-use test. You're doing a live test on what your how effective your disinfectant is. So resolution. Oh man, this was so long ago. So Roberta, let's see, she developed pyelonephritis. It's a severe kidney infection. I can feel what that pain was like for Roberta. So she was placed in the ICU. She continued to deteriorate, symptoms of septic shock. Obviously, if you get an infection in your kidney, there's potential access to a lot of other body systems, right? So let's see. We tested a range of antibiotics, and her infection was caused by, here we go, CRE. A carbapenem-resistant Enterobacteriaceae. So it's a drug-resistant family of bacteria normally found in the digestive system. When CRE is introduced to other body systems, that might occur through improperly cleaned surgical instruments, catheters, or endoscopes. Aggressive infection can occur. Oops. Here we go. And here we go. So it's notoriously difficult to treat. Fatality rate up to 50%. Roberta was treated with dialysis, IV fluids, medication to maintain blood pressure, prevent blood clotting. And she was also started on an aggressive treatment with intravenous administration of a new drug called, tigacycline. I usually don't read that part, I guess. Several weeks, she starts to recover, and they eventually work out that there was a contaminated, duodenoscope that was used on her before. All right, so here's a colorized SEM of the CRE. And again, the drug-resistant strain is typically associated with hospital-acquired infections, nosocomial infections. And that's your duodenoscope. So the elevator mechanism, here we go, right here, has crevices that are difficult to disinfect. So pathogens that survive disinfection protocols can be passed from one patient to another, causing serious infection. That brings us to the end of Chapter 13. Let's close that out and open Chapter 14 at the beginning. All right, this is where we're moving into looking at antimicrobial drugs. So first mass produced in the 1940s, penicillin was instrumental in saving millions of lives during World War II and was considered a wonder drug. Today, overprescription of antibiotics, especially for childhood illness, has contributed to the evolution of drug-resistant pathogens. So here's the outline of this chapter. This one has a lot of sections. So we have a little bit of history, some fundamentals of antimicrobial chemotherapy, mechanisms of the antibacterials, drug resistance, testing the effectiveness of antimicrobials, and then current strategies for antimicrobial discovery. History of chemotherapy and antimicrobial discovery. Okay, so compare and contrast natural, semi-synthetic, and synthetic antimicrobial drugs. Describe the chemotherapeutic approaches of ancient societies. I mean, there's just like a slide on that. Maybe there's other things I'm not remembering. Describe the historically important individuals and events that led to the development of antimicrobial drugs. Yay. All right, so for millennia, Chinese herbalists have used many different species of plants for the treatment of a wide variety of human ailments. And they have some efficacy here. I'm not saying that traditional medicine has nothing to offer, by no means. In fact, we plunder that kind of knowledge from every culture to find, refine, and mass produce whatever antimicrobials we're able to come across. All right, so our clinical focus in this chapter features Marissa, a 52-year-old woman who was suffering from severe abdominal pain, swollen lymph nodes, fatigue, and a fever. She had just returned from visiting extended family in her native country of Cambodia. While abroad, she received medical care in neighboring Vietnam for a compressed spinal cord. She still has discomfort when leaving Cambodia, but the pain increased as her trip home continued, and her husband drove her straight from the airport to the ER. Her doctor considers whether Marissa could be suffering from appendicitis, a UTI, or pelvic inflammatory disease. However, each of those conditions is typically preceded or accompanied by additional symptoms. He considers the treatment she received in Vietnam for her compressed spinal cord, but abdominal pain is not usually associated with spinal cord compression. He examines her health history further. Okay, so Paul Ehrlich, he discovered what was called Compound 606. It was an antimicrobial agent that proved to be an effective treatment for syphilis. Because until then, and still now in some parts of the world, syphilis is a lifetime kind of infection. You'll have primary, secondary, tertiary syphilis. Primary will appear to resolve itself. You lesions and sores, right? And then it can be months or years later. You have secondary syphilis appear, include symptoms like on your hands, rashes. And then tertiary syphilis is where you can start losing your nose and whatnot. It can also be accompanied with mental issues. I'm going to try to play this, but it might not work in this. But let's just try it. This is from Frankenstein Chronicles on Netflix. And I might have to show it to you live in person instead. Yeah, I will. All right. Moving on. So Alexander Fleming is the man credited with discovering penicillin in 1928. And this was a story of basically he left some plates out in his lab. He didn't clean his lab up. He went on a trip or a vacation or a conference or whatever, came back and found this mold growing on the plates. And then the area around the mold had no more bacteria in it, or had no bacteria in it. So that was the discovery. The discovery was was based in poor lab practices. So, but it wasn't until the 1940s that Howard Florey and Ernest Chain discovered how to scale up the production of it. They figured out how to purify it and showed its efficacy as an antimicrobial in animals and human trials in the early 1940s. And there's something I got to circle back to mention again, that other research that was going on that was horribly unethical, that whose participants who did not give informed consent to participate were also denied penicillin. All right, so Selman Waxman, the first to show the vast antimicrobial production capabilities of the Actinomycetes, group of soil bacteria. You know what? I think I'm going to call it here today. And we'll go into the fundamentals of antimicrobial chemotherapy. Wait, let me look. Yeah, let's do that. Let's start that on Wednesday. Okay, so have a good day. The rest of your day. I am going to, see y'all on Wednesday. And then